Today's lesson is on solving radical equations. So far, we've just been dealing with expressions, simplifying expressions with radicals, but now we're going into equations. We're going to have an equal sign, and we'll be solving for x to get a solution. So before we begin fully solving these, I'm going to just talk about some simple ideas of inverse operations, which we use to solve equations. So the first one, x squared equals 324. So this is asking you what number, when you square it, equals 324. Well, if you don't know the answer to that, what you can do is the inverse of something squared is a square root. And you can square root both sides. Square rooting something squared, they cancel each other out, leaves you with just x. And then the square root of 324 is 18. Technically, plus and minus 18. All right, so now an example, kind of looking backwards. What if we have the square root of x equals 8? This is asking, when you square root, what number gives you the answer 8? Well, if you're not sure, inverse operations. The opposite of square root is something squared. Squaring a square root would cancel, and it leaves you with just x equals, and then 8 squared is 64, which makes sense. The square root of 64 is 8. And then the last one would be the cube root of x equals 7. So what number, when you cube root it, equals 7? Same idea, except the opposite of a cube root would be to the third power. You cube a cube root, they cancel. So you're left with x equals 7 to the third power is 343. Now, when solving radicals, you sometimes have what's called an extraneous solution. So you might want to pause the video and write this down quick. An extraneous solution is when solving radical equations, the result, so the answer, may be a number that does not actually satisfy the original equation. So maybe you go through and you follow all the steps correctly, but when you check your answer, it might not actually work. So it's super important when you're solving radicals to always check your answer. All right, so now for our first example of officially solving a radical equation. So let's say I have the square root of x plus 2, and then plus 4 outside of the square root equals 7. All right, so for this example, the first thing we need to do is isolate the radical. We need to get that by itself. So what I'm going to do is this inverse operation, just subtract 4 on both sides. So that leaves me with the square root of x plus 2 equals 7 minus 4 is 3. Once the radical is isolated, I need to get rid of it. So how do you get rid of a square root? We would square it. Whatever you do to one side, you need to do to the other. So squaring a square root would cancel it out and leave you with whatever's underneath. So x plus 2 equals 3 squared is 9. And then, now all I'm left with, minus 2, minus 2. So x equals 7. And then remember the last slide, check for extraneous solutions. So go back up. Let's see, the square root of our answer 7 plus 2 plus 4, will that equal 7? Well, 7 plus 2 is 9. The square root of 9 is 3, and 3 plus 4 equals 7. So in this case, it works. That is our solution. All right, example number 2. The square root of 7x minus 2 equals the square root of x plus 3. So this time we have a square root on both sides, and they're isolated on both sides. So we don't have to isolate them. We can go straight into getting rid of them. And what we can do is immediately just square both sides. Cancel out, cancel out. Both sides will leave you with what's underneath. So 7x minus 2 equals x plus 3. So just basic solving. We do have variables on both sides. So I will subtract x. So 7x minus x. 6x minus 2 equals 3. Add 2, add 2. So 6x equals 5. And then divide by 6. So x equals 5/6. And now I need to check my solutions. So I just am plugging in my answer in for x on both sides. All right, so let's simplify. So 7 times 5/6, that's going to be 35 over 6. And to get a common denominator, I'm going to turn the 2 into 12/6 equals the square root of 5 over 6. And I'll get a common denominator, and I'll change this to 18 over 6. So then I will have the square root of 23 over 6 will be equal to the square root of 23 over 6. So this one also checks. All right, our last example, 5x minus 7 in parentheses to the power of 1/3 plus 3 equals 5. All right, so we're solving radicals, but we don't have a radical. However, if you remember, a rational exponent means a radical. So this is the same thing as saying, oh, the cube root of 5x minus 7 plus 3 equals 5. First thing is we need to get that radical isolated. So we have to get rid of this plus 3. So I will first subtract 3, subtract 3. So the cube root of 5x minus 7 equals 2. Now that it's isolated, so let's think, to get rid of a cube root, I would raise it to the 3rd power on both sides. So I'm left with 5x minus 7 equals 2 to the 3rd power is 8. Plus 7 plus 7. So 5x equals 15. And x equals 3. All right, let's do a quick check. 5 times 3 minus 7 to the power of 1/3 plus 3 equals 5. 5 times 3 is 15. 15 minus 7 is 8. And that means cube root. So the cube root of 8 plus 3, does that equal 5? The cube root of 8 is 2. 2 plus 3 equals 5. So all of our solutions have worked. I did that on purpose. Our next part B, solving radicals, is where the extraneous solutions really start to show up. But there is your kind of intro to solving equations with radicals. Good luck.